Today we're going to look at section 9.2, talking about series and summation notation. So after this lesson, you should be able to write series using what's called sigma notation. We'll take a look at that. And find the sum of a series. Now, a series is the indicated sum of the terms of a sequence. We looked at sequences, which is just a set of numbers. Now, a series is we're going to add up all those numbers. And for instance, a sequence might look like this: 1, 2, 3, 4. The series would be those four numbers added together: 2, 4, 6, 8, and dot, dot, dot. The series is going to be 2, 4, 6, 8, dot, dot, dot. So it's going to be an infinite series. Then here we've got 1/2, 1/3, 1/4, 1/5, 1/6, and the series would be adding them all up. So because many sequences are infinite and do not have a defined sums, we often find what are called partial sums. A partial sum, indicated by S sub n, is the sum of a specified number of terms of a sequence. So S sub n, we're going to add up the first n elements in a sequence. So summation or sigma notation, very common in mathematics, is the capital sigma there that you see, and below it we have some index. It could be I, J, K, N. It doesn't really matter, but we're going to use it inside the sequence or pattern to help us add them all up. So we start with some index here, and we're going to end with the index that's listed on top. And we'll look at some examples of this. So a finite series is going to be of the type 2 plus 4 plus 6 plus 8, and we're done. We could write that as the sum, that's what I'm going to call that, from n equals 1 to 4 of 2n. So that's going to look like 2n times 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and then we're going to stop there because 4 is our highest index, and that's the end of that. An infinite series would be 2, 4, 6, 8, and it goes on forever. We would represent that as n equals 1, the sum of n equals 1 to infinity of 2n. So we're going to add up 2, 4, 6, 8, and obviously that's going to be infinite. So let's take a look at these a little bit more complicated using sigma notation. We need to find what the pattern is. So if I look here, this looks like, oh, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. And our last one, well, that looks like would be 7 cubed. So I'm sorry, 9 cubed, not 7 cubed, 9 cubed. So that would be the sum of n equals 1 to 9 of n cubed. So 1 cubed plus 2 cubed plus 3 cubed, all the way up to 9 cubed. And we could figure out what that value is if we wanted to. Now here is an infinite series. So it's going to go from sum of 1 to infinity of n over n plus 1. So here is 1 over 2, 2 over 3, 3 over 4, 4 over 5, and it would go on infinitely after that. Again, the counter, or the index as it's called, doesn't really matter. A lot of times we'll see I, but it could be JK, and doesn't really matter. Okay? If we use I, remember that's not the imaginary number I. It's just an index I. All right, some general properties that if we're multiplying some function by a constant, we could factor out that constant and put it in front. We could do the entire summation and then multiply by the constant. It's kind of like the distributive property. Here, if I've got two sums of some f of n and a sum of g of n, as long as we have the same starting index and ending index, that we can add that those two functions together and take the sum. Same thing with subtraction. As long as we have the same starting and ending index on these, we can represent it this way. So that's just some properties that we'll want to know. The index does not have to be I, nor does it have to start at 1. 1 is very common, but sometimes we're going to start at 0, and for some other ones, it might have different indexes. We just have to be very careful to make sure we understand the problem before we just assume that it's 1. For a series with many terms, we have a few shortcuts. If I am just adding up some constant c 1 to n times, well, that's just that constant times n. If I'm adding up from 1 equal to n of just k, so it's going to be 1 plus 2 plus 3, we could represent this, and then we could prove this if we wanted to, but you can just take my word for it here. That's going to be the upper limit n times n plus 1 divided by 2. So if I was going to sum up the first 10 numbers, it would be 10 times 11. So that'd be 110 divided by 2, which would be 55. If we're going to add up k squared from 1 to n, and do it n times, it's going to turn out to be n times n plus 1 times n 2n plus 1, all divided by 6. And again, we could prove that if we wanted to, but we'll just assume it to be true for right now. All right, let's take a look at some examples here. Find the sums of the following series. Well, the easiest way to do it would just be to write out the entire series. So here it's going to be from 1 to 3. So if k is 1, it's going to be 1 squared minus 7 plus 2 squared minus 7 plus 3 squared minus 7. Then I can add that up. 1 minus 7 plus 4 minus 7 plus 9 minus 7 turns out to be negative 7. Let's look at this one. We're going to do 5 terms this time. So it's going to be 1 plus 1 plus 2 plus 1 plus 3 plus 1 plus 4 plus 1 plus 5 plus 1, which turns out to be 2 plus 3, 4, 5, 6. And if I added those all up, it would turn out to be 20. Now, I'm not going to go into a lot of detail here, but the summation function is available on your calculators, on your TI-84s and TI-83s. It's under the math functions. Under summation, you can look for this, the correct function. And then it's going to give you the sigma, but then it's going to ask, well, you need to enter the index, you need to enter the start value, you need to enter the stop value, and then you need to enter the pattern. Now, one thing that's tricky about the calculator is it's going to give you a set of parentheses. So you have to put this term inside the set of parentheses that it gives you. So like I said, I'm not going to go into a lot of detail about that. There are plenty of YouTube videos out there about how to do stuff like this. So if you're not quite sure how to do it on your calculator, go check out one of those TI YouTube videos, and it will help you to do this. But that's a very, very powerful tool on your calculator, so that you don't have to add them all up, especially when the upper index starts to get very large. It's very nice to do it on a calculator rather than do it by hand. I'm not sure anyone's got an older calculator, but if you do, I'm sure there's videos out there for that too. So check that out on your calculator. Make sure you know how to do that, and it'll really help you. All right, so your homework is listed there. Again, some Alex suggestions. And if you have any questions, let me know. But I don't think it's going to be too awfully difficult. So hopefully you can figure that out. So that's all we're going to do for today.